Last class, we started an introduction to chemical reactions. We learned what they are, some signs that a chemical reaction happens, and some vocabulary that went along with it. One of the vocabulary that we talked about was coefficients and balancing equations. So chemical reactions must be balanced. So we are going to learn how to balance them today. And we're going to do this by a method called balancing by inspection. So when you think of the word inspection, you think like maybe a car. When you have to get your car inspected, they look over all the different things to make sure that they kind of work properly and that your car can run fine. So we're going to balance by inspection in a way where we are going to look at products and reactants and add coefficients. So when things are bad in a car, they will fix the parts or add something to the parts to make sure that they are a whole. So we are going to look at the reactants in the products and see that they are balanced. And we have to do this to satisfy the law of conservation of mass. That law of conservation of mass says that nothing can be created, matter can't be created nor destroyed. So we need to have the same amount of matter on the left and the right of the equation. And one big rule for balancing equations is you can never change the subscripts. So we are only going to balance equations by adding coefficients in front of the chemical formulas. We're never going to change those small numbers in the formula. You cannot change the physical formula. You are just adding coefficients to balance out the atoms in the formula. So there's a certain step to doing these, and I laid them out 1 through 3. We'll go over examples and refer back to these steps. So the first step is write a correct formula for the reactants and the products involved in the reaction. So some of them will be in words. Some of them they'll have the formulas written already. So the ones we're going to go over today have them written out already. The next step is to determine the number of atoms of elements in each formula. And we'll do that in the examples. You can do this simply by looking at the subscripts and seeing how many atoms of the elements you have on each side. The next step is to use coefficients to balance the numbers of atoms of each element on the two sides of the equation. So this is now where you will look to see how many atoms you have of each, and then if they aren't the same, you will add coefficients to make them the same. Some examples. So these will already have number 1 done for you. All of the examples we're going to go over today are already written out in the correct formulas. So you will have to start at part 2 or step 2. Determine the number of atoms of elements in each formula. So we are going to do that by looking at the subscripts and seeing how many elements we have for each side. So when you start with these problems, I want you guys to put a line down where the arrow is, because we have reactants and then the products. We will have to have the same number of atoms on the reactants and the products side. So you want to make sure that they're separate and you're counting them for each side. So if we take a look on the left of the equation, the reactant side. We have Fe and we have S. Those are two different elements. That's iron and sulfur. If you take a look, we're going to count how many atoms are on each side. We're going to do this by looking at the subscript. The subscript on iron, there is not a subscript, so we can say that that means that there is one iron. And same thing with sulfur. If it would have any other number of atoms, you would see a number as a subscript next to it. So we have one iron and we have one sulfur. If you take a look at the product side now, you will see that we also have an iron and a sulfur. And if you take a look at the subscripts next to them, we don't have any numbers next to the elements. So that means that there are one of each of those. And this equation is actually already balanced. We can see that it's already balanced by looking at all of the irons. There is one on the left side, there's one on the right side. So we're good with that. We don't need to add a coefficient. The sulfurs, or the S's, there is one on the left side and one on the right. So that means that our equation is balanced. It satisfies the law of conservation of mass because we have the same amount of iron and sulfurs on the left and the right. So this is really the easiest example you can see. The next example is an example that actually we can see some subscripts in, and you will have to add a coefficient. So one thing I said, you can never change the chemical formulas or the subscripts that are with them. We will always add coefficients in front. So I'm going to put little numbers or little underlines right here, and that will show you where we will put coefficients when we need to. So we're going to start this problem by splitting up the reactants and the products. We can do that by looking for the arrow, which means yields, in this case, of the chemical reaction. So if we take a look on the left side of the chemical reaction, or the reactant side, we see that we have a hydrogen and we see that we have an oxygen. This is now where we can see how many we have. That H has a 2 next to it, so that means that there are 2 hydrogens in the reactant side. Oxygen also has a 2 next to it, so that means that there are 2 oxygens on the reactant side. Now, on the product side, we also see that we have an H and an O. There is a 2 next to the hydrogen, so that means that we have 2 hydrogens. There's not a number next to that oxygen, so that means we only have 1 oxygen. So if we take a look, we don't have the same number of oxygens on the reactant and the product side. So this is where we will need to add a coefficient to make those equal the same numbers, or the same matter on each side. I had to move this over a little bit, but it looks the same as what we did before. Once we realize that the number of atoms aren't equal on the reactants and the product side, this is where we now have to start adding coefficients. When you are starting your process of adding coefficients, this is where really inspection comes into play. So you have to inspect each side and see what number could be added as a coefficient to make the atoms equal. And this is kind of a guess and check method. If you see that you add a coefficient and they aren't equal on both sides, you can just simply erase and try a different one. So this will make more sense as we do this example. If we take a look on the reactant side, we have 2 oxygens, and on the product side, we only have 1. We can add a coefficient of 2 in front of this H2O, and that will mean we have to multiply both of these numbers, because now that there are two H2Os, that means that we now have 4 H's and we have now 2 oxygens. So if we take a look, our oxygens are now equal. But because we added a coefficient in 2, that coefficient will multiply the whole formula. So it won't just multiply that oxygen, it multiplies that hydrogen also. So we then change the hydrogen number. So it is not equal to the reactant side. We only have 2 hydrogens on the reactant side. So now we need to do something to this 2 to make it equal 4. What can you multiply 2 by to get 4? That is like just what we did on the other side. We can add another 2 in this front, and that will make it equal 4 hydrogens on the left and 4 hydrogens on the right. So once you finish adding your coefficients, you can do this kind of check method again. Now, on the left, we have 4 hydrogens. On the left, we have 2 oxygens. On the right now, we have 4 hydrogens and we have 2 oxygens. They are all equal, so we could say we have the same amount of matter on the reactant side and the product side. So this is now a balanced reaction, and it is a completed reaction. Everything's equal, and it satisfies the law of conservation of mass or matter. So if we take a look at the next example, I'm going to start by adding lines for the coefficients so you can see what numbers I'm placing in front. And I'm going to add a line on the yields arrow so that we can tell what is a reactant versus a product. So if we take a look at the reactants, we have S8 plus O2. So those are 2 different elements. We have S, and we have 8 of them. We have an O, and we have 2 of those oxygens. If we look at the product side, we have an S and an O, but we only have 1 S and we have 2 O's. So we can tell by looking at these numbers that we do not have the same amount of atoms on each side. So we have to now add coefficients in front and really inspect each side of the reaction to see how we can get them to balance. So on the left side, we have 8 sulfurs, and we have 1 sulfur on the right side. We can add a coefficient in front of a number 8 to get this number of sulfurs to equal 8. But when we do that, we also have to add an 8 because that coefficient distributes to the sulfur and the oxygen. So we have to multiply the number of oxygens by 8 also. So now we have 16 oxygens on the right side. On this side, we are now good with sulfurs. We have 8 and we have 8. So we are good with that. Now we just have to look to see the oxygens. We have 16 on the product side. We only have 2 on the reactant side. So what number can we multiply our reactants by number 2? What number multiplies by 2 to equal 16? So we need to have a total of 16 oxygens on each side. So if we think of our multiplication facts, or even you can do division in this case, what's 16 divided by 2? That is going to be 8. So we need to add that coefficient of 8. So we have a total of 16 oxygen. So if we want to check the answers, we will take a look on the left reactant side right now. We have 8 sulfurs. We have 8 times 2, which is 16 oxygens. On the right side, we have 8 sulfurs. And then 8 times 2, we have 16 oxygens. Everything is equal, and our law of conservation of mass is obtained and satisfied. So our chemical reaction is the following, and the next example is a good example because we now see something that we went over in the writing formula unit. We see something like SO4. SO4 was the ion for sulfate, and it was polyatomic because it had multiple atoms in that ion. So we are going to treat polyatomic like one element. So when we count up our elements, we are going to treat them like one element. I don't even know. Okay. So I'm going to put the line for coefficients in front like we just did and separate our products and reactants. So if we look at our reactant side, the left side, we have 1Ba, we have 2 Cls, we have 2 NAs, and then we have 1 sulfate. If we had more than one sulfate, we would see parentheses and a number outside of the parentheses. Now we can take a look at the product side. We have 1Ba. We have 1 sulfate again. We now have 1 sodium or Na. We have 1 Cl or chlorine. So the only numbers that are different from the left and the right side are our Na and Cl. What coefficient can we add on either side to get these to equal out? So we're going to add a coefficient on the right side, the product side, because they're different than the number on the reactant side. So what number could you multiply NaCl by to get each of these to equal 2 like on the reactant side? If we would simply add a 2 in front of that NaCl, we would have a balanced reaction. If you try to check our work, we have 1Ba, we have 2 Cls, we have 2 NAs, and 1 sulfate. On the right side, we have 1Ba, 1 sulfate. Now we have 2 NAs and 2 Cls. So we are good with all of our numbers. They match up, and our reaction is completely satisfied and balanced by those coefficients. So we're going to start the last example by doing the same thing. I'm going to add lines for the coefficients, split up the reactants and products, and look to see how many elements or atoms we have on each side. We have an Fe, a Cl, and then another Cl. I'm going to split these up just so you can see the total number of each. So we have 1 iron, we have 2 Cls in iron chloride, and then we have 2 Cls also on that second reactant. On the product side of the reaction, we have 1 iron and 3 chlorines. So we can see that we don't have the right number of chlorines on each side. So this is where, like I said, this is a guess and check method. So you can add a coefficient to either side just to try to get equal numbers on both sides. So I usually, when you're in this position, when you kind of have not a certain amount or certain way to figure out how to balance, I would always start with a low number. Like, in this case, I would start with putting a 2 in front to see how you can balance or how that will change your reaction. So if you add a coefficient of 2 on the product side to change those chlorines numbers, because that's what we're trying to do in this case, you will see that we now have 2 irons or Fe's, and we have 6 chlorines. And this is where, once you finish one side of the equation, you now have to go back to the reactants. So we just added a 2 in front of the products, and that changed the iron from having 1 iron to 2 irons. So if we add another coefficient to balance out the irons, if we add a 2 because we need to make them equal on that side, we now will have 2 irons and 4 chlorines. So now we can take a look to see if all of our atoms, by adding those 2 coefficients, if they will balance out. So on the reactant side, we have 2 irons, we have 4 chlorines, and then we have another 2 chlorines. That equals 6 chlorines. And on the product side, we have 2 irons, and then we have 6 chlorines. So our whole reaction is balanced, and the law of conservation of mass is satisfied. So in these problems, you're going to have to go back and forth, try different numbers in front of the reactants and products to get them to equal the same number of atoms. So it's a little tricky because you do have to go back and forth, and it is kind of like a guess and check method. You're guessing to see what number would be best, but it also is a trial and error process where if it's wrong, you can just erase that part that you just did and add a different number to get the number of atoms to equal the same on the reactants and products. So if you have any questions on this, you are able to ask them in the last 20 minutes of class. You are now to work on a worksheet on Classroom. You are going to make a copy of the Google document that I uploaded on Classroom, and you will add your coefficients in. If you want to show me your work, you can do that also. But I will be there to answer questions, and you will have to balance equations for the rest of the chapter.